Hello everyone, this is Sareen from Exam Help Web. Today we are solving Chemistry Paper 2 AS Level Structured Questions 9701 Paper 2 Variant 1 May-June 2019. Our very first question says Group 2 elements share common chemical properties. Calcium reacts in cold water more quickly than magnesium because more energy is required to remove the outer electrons in magnesium. This occurs even though calcium atoms have a greater nuclear charge. Explain why more energy is required to remove the outer electrons in magnesium than in calcium. Okay, so when you look into your periodic tables, you see that magnesium has been placed higher in group 2 than calcium. Thus because magnesium has its valence electrons nearer to nucleus than calcium does. Thus less shielding, hence force of attraction between the outermost electrons and nucleus is more. Magnesium has its valence electrons nearer to its nucleus than calcium does, thus less shielding, hence force of attraction between valent electrons and nucleus is more. The more the force of attraction, the higher the energy is required to remove the electrons from its shell. Okay, moving on to next part. 0.001 mole of strontium reacts with an excess of cold water. When the reaction is complete, a colorless solution is seen. Construct the equation for the reaction of strontium with cold water, include state symbols, and 2 marks have been assigned. So 1 mark goes for the correct equation and the second mark goes for the state symbols. Sr, this is in a solid form, plus H2O, and then this is liquid. This gives strontium hydroxide plus hydrogen. Strontium hydroxide, it says when the reaction is complete, a colorless solution is seen. A colorless solution means whatever was formed has dissolved. So this will be in aqueous state then. And hydrogen will be a gas. Now we have to balance this equation too. Never forget balancing them. Equations always need to be balanced in your chemistry papers. So that's it. Part 3, 0.005 moles of calcium and 0.005 moles of strontium are added separately to 2 beakers. Each beaker contains 100 cm³ of cold water. At the end of each reaction, a white solid and a colorless solution are seen in both beakers. Okay, so predict which element, calcium or strontium, produces the more alkaline solution. Explain your answer. Since hydroxides get more soluble as we go down group 2, thus strontium produces more alkaline solution, or you could say strontium hydroxide dissociates more into the solution. So we'll write over here, since hydroxides get more soluble, the more soluble it is, the more acidic or alkaline solution will be. So get more soluble as we go down group 2. Thus, strontium produces more alkaline solution or dissociates more. Strontium hydroxide dissociates more. So this is the answer. Part 4. Describe one observation when magnesium carbonate is added to excess dilute sulfuric acid. So you have to describe what you see, one observation, but right before that I'll write the equation. Magnesium carbonate is MgCO3 plus H2SO4. This gives you, okay, so this is a metal carbonate. It reacts with an acid, so the reaction will be metal oxide plus carbon dioxide plus water. So this will become MgSO4. Since MgSO4 is a salt, MgSO4 plus water plus carbon dioxide. So it says you have to describe one observation. There are two things forming. One is MgSO4 and one is carbon dioxide gas. This is in a gaseous form, and then this is in a this will dissolve now, because MgSO4 sulfates, they get more soluble as you ascend group 2. As you ascend group 2, SO4 means sulfates will dissolve more and more, because Mg has been placed a lot higher than any other elements in group 2, so will of course dissolve in the solution. So you can either write that white solid dissolves, because group 2 elements will always have a color of white. White solid dissolves, or you could even say that effervescence is given off due to carbon dioxide gas formed. Alright, so you can write either. Okay, now moving on to part B. Element X is a metal. X reacts with oxygen to form a black solid oxide. The oxidation state of X in this oxide is +2. The carbonate of XCO3 is a green solid. It decomposes on heating to form the oxide and a colorless gas. Part 1. From the information given, state two similarities and one difference that metal X and its compounds have with group 2 metals and their compounds. Okay, so element X has an oxidation state of +2, and group 2 metals also have an oxidation state of +2, so that's one similarity. I'll write that over here. They both share oxidation states of +2. That's one similarity. The next similarity would be, it says that X carbonate will decompose on heating to form the oxide and a colorless gas, and so will group 2 carbonates. So that's another similarity, that they will give off a colorless gas and they will form a metal oxide too. So they both give out colorless gases and form metal oxide on heating. Now they're asking for one difference between the properties of this element X and group 2 metals. So over here it says that X reacts with oxygen to form a black solid oxide, and it also says that X carbonate is a green solid, while group 2 elements will always have a color of white. Group 2 oxides or group 2 carbonates will always have a color of white, while over here X carbonate has a color of green and X oxide is a black solid oxide. So that's a difference. So we can write oxide and carbonate of X being colorful, while oxides and carbonates of group 2 elements are white in color. Part 2, write the formula of the oxide of X. So X has an oxidation of +2, or oxygen has an oxidation of 2-. So when you cross multiply that, the oxide formula will be simply XO. That's it. Part 3, write an equation for the reaction of XCO3 when it is heated. So when a metal carbonate is being heated, it forms, over here in the question it also states it decomposes on heating to form the oxide and a colorless gas. So XCO3, X carbonate, will give you metal oxide plus carbon dioxide. Alright. Now question number 2. Magnesium silicide is a compound made by heating magnesium with sand. Part A, draw a dot and cross diagram to show the arrangement of outer electrons present in a formula unit of Mg2Si. Assume magnesium silicide is an ionic compound. So in ionic compounds, one will donate electrons and the other one will accept electrons, while in covalent compounds, they both will be sharing electrons with each other. It says that consider that a magnesium silicide is an ionic compound, so one has to share or two has to share and the other one has to accept. So over here, so silicon is not a metal, it will probably accept electrons, while Mg, there are two Mgs, mean there are two atoms of magnesium which will be donating electrons to silicon. So this is silicon, it has its own 4 outermost electrons and it needs 4 more to complete the valency of the shell, while Mg over here will be donating 2 of its electrons to silicon. So 2 of magnesium electrons will come here and the other Mg will be donating electrons the same way. So 2 of this Mg on the left will be here, 2 of the electrons over here. So Si must have gained -4 charge because it has gained 4 electrons, while Mg now has a complete outermost shell because it has lost its 2 valent electrons and it has gained a charge of +2. This also has gained a charge of +2 because this one too has lost 2 of its outermost electrons and has completed its outermost shell. So this is the diagram. You must indicate what symbols you're using to represent different electrons. Over here I have used these circles to represent silicon electrons and these crosses for magnesium electrons. So I'll mention this over here for the examiners. So this is equal to and this is equal to. I'm using circle for silicon electrons and I'm using crosses for magnesium electrons. Okay, so you must mention that too. Now part B, when solid magnesium silicate is added to water, Silane gas CiH4 and a solution of magnesium hydroxide are produced. Construct the equation for this reaction, include state symbols, and the first mark will go to your correct first mark is for your correct equation and the second mark is for the state symbols. So it says when Mg2Si, when solid Mg2Si means I have to indicate that over here, solid, plus is added to water, which is a liquid, it gives Silane gas, which is SiH4, and it's in a gaseous state, plus and a solution of magnesium hydroxide are produced. So magnesium hydroxide is Mg bracket OH bracket close 2, and a solution means it's in aqueous state. It's in aqueous state. Now you have to balance this again. Balancing is an important part. So over here I'll write 4 and over here I'll write 2. Alright, now part C, suggest with reference to structure and bonding why SiH4 is a gas at room temperature. So SiH4, since both of them are non-metals, there must be covalent bonding in between them. And why do they exist as a gas at room temperature is it's due to them being simple molecular structure, because SiH4 has a simple molecular structure with weak intermolecular forces. There are 2 reasons. 2 marks means the first mark is for a simple molecular structure and the second mark is for the weak intermolecular forces. You have to describe your answer in terms of both forces and the structure. First of all, what kind of bonding is present, and secondly, what strength the intermolecular forces possess. Now part D, the table shows the electronegativity values of carbon, hydrogen and silicon. Part 1, CH and SiH bonds have weak dipoles. Use the electronegativity values in the table to show the polarity of C2H and Si2H bonds. Okay, so over here you see C2H and then there is Si and H. When you look into the table, carbon has a higher electronegativity than hydrogen. So this means carbon will have a partial negative charge and hydrogen will have a partial positive charge. While in this diagram, Si2H, silicon has a lot lower electronegativity than as compared to hydrogen. So Si will have a partial positive charge while hydrogen will have a partial negative charge. Alright. Explain why methane CH4 has no overall dipole moment. Since CH4 has a tetrahedral shape, which leads to partial charges on C2H getting cancelled. So I'll write, since CH4 has a tetrahedral shape which leads to partial charges on C2H getting cancelled. I'll draw the structure of methane over here and then I'll show you how the charges are getting cancelled. So this is carbon in the middle and then there is this first hydrogen and then there is this second hydrogen, third hydrogen, then there is this fourth hydrogen. Since carbon has a higher electronegativity than hydrogen, so carbon will have a partial negative charge and hydrogen will have a positive charge, and then over here positive and positive and then positive. How do you represent positive and negative charges and partial charges? You represent them with the help of arrows. Head will represent more electronegative element and tail will represent the less electronegative atom. So over here carbon is a highly electronegative atom as compared to hydrogen, so it will have an arrow over here and an arrow over here and over here and over here too. This C and H over here, they share electronegativity which this also shares, so this and this gets cancelled because they are right in front of each other. This C and H over here, they share same electronegativity as this one, so this one and this one also gets cancelled. This is how there will be no overall dipole moment existing on the structure of methane. Part E, SiH4 reacts in air without heating, but CH4 must be ignited before combustion occurs. Suggest with reference to bond energies from the data booklet why SiH4 reacts in air without heating, but CH4 must be ignited. Bond energy for C to H is 0.4. How do I get 0.4? I'll subtract the value, I'll subtract the electronegativity value of C from H, so that I get the bond energy of C to H, and that for Si to H is 0.3. So the bond energy of Si to H is 0.1 less than C to H. Thus, higher the bond energy, the more the energy is required to break the bonds. And that's why SiH4 requires no prior heating. Part F, silicon dioxide reacts with hot concentrated sodium hydroxide. Identify the two products formed during this reaction. So silicon dioxide reacting with sodium hydroxide, it will give you water and sodium silicate. So I'll write here water and sodium silicate, or you can write the formula too. So H2O plus sodium silicate. Describe the behavior of the silicon dioxide during this reaction. Since silicon is a non-metal and silicon dioxide is a non-metal oxide, it acts as an acid. Now, question number 3. Construct an equation for the second ionization of argon. Ionization energy is an energy required to remove one electron from the outermost shell of an atom. That would be first ionization energy. Second ionization energy means the atom has already been converted to an ion, a positive ion, and now we are removing one more electron from its outermost shell. So, argon already exists as an ion, and now one more electron is being taken away from its outermost shell, so this becomes +2 plus electron. Now argon has a charge of +2 because one more electron has been taken away from it. Now part B. The graph shows successive ionization energies for the element argon. Complete the graph with predictions for the 8th and 9th ionization energies of argon. Use a cross for each data point. Okay, so its first 7 ionization energies have been given to you. The crosses represent the first 7 ionization energies of argon. Okay, so 8th and 9th we have to mark over here. Since you all know that argon is a noble gas, which means it has a complete outermost shell. Its outermost shell should have 8 electrons, which means its 8th ionization energy must be very similar to its last 7. So we will draw the 8th ionization energy somewhere over here. Now when we talk about its 9th ionization energy, we have already emptied one shell of argon completely, and this electron is in shell which is now nearer to nucleus. In other words, this electron has a lot high energy than its last 8 electrons, because they were from farther shell, and hence ionization energy for this electron will be a lot more than the previous 8 electrons. So there will be a drastic increase seen in the graph. Now the 9th ionization energy will be somewhere nearer to 10th ionization energy. So okay, so 9th is this one. This will be nearer to the 10th ionization energy. So I'll draw it over here. Okay, there is an increase because there is a change in the shell. Part C. The energy value required to remove the first electron from an atom of argon is circled on the graph. Sketch the shape of the orbital that contains this electron. So the first electron from an atom of argon. First, I'll write all the orbitals of argon. 1s2, 2s2, 2p6, 3s2, 3p6. Since argon has an atomic number of 18, that means that it has 18 electrons, a complete outermost shell also. So the first electron is being taken away from the argon atom, means the first electron is being taken away from the p orbital. So we'll sketch the shape of that orbital. Now p orbital looks like this. Part D, chlorine exists as a diatomic gas. A sample of chlorine was made during a chemical reaction. When measured at 404 kilopascal and 25 degrees Celsius, the sample occupied a volume of 20 centimeter cube. Part 1, calculate the mass in grams of Cl2 formed. For this calculation, assume that chlorine behaves as an ideal gas under these conditions. Okay, so the formula for ideal gases is pressure into volume is equals to number of moles into the gas constant into temperature. Now pressure needs to be in Pascal, volume needs to be in meter cube. Number of moles over here, R has a constant value of 8.314. Temperature needs to be in Kelvin. So pressure for us is 404 into 1000, since over here in the question it is in kilopascal, so we must convert that into pascals. Now volume, which is given to us, is in centimeter cube. We need to convert centimeter to meter cube. So into 20 divided by 100 to the power cube is equals to number of moles is mass divided by molar mass. So mass we don't know, divided by molar mass of chlorine gas. Chlorine gas exists as a diatomic gas, means the molar mass of chlorine will be multiplied by 2 to get the RFM. So 2 into 35.5. Okay, so this gets multiplied with 8.314, which is a constant value for temperature, into our temperature is given in Celsius. We need to convert that to Kelvins. We'll add 273 to 25. So here 25 plus 273. So our answer for mass will be equal to 0.232 grams. Right? Part 2, calculate the number of chlorine atoms in this sample of chlorine gas. You may find it helpful to use your answer to D part 1. If you are unable to calculate an answer to D part 1, use 0.36 grams of chlorine. This is not the correct answer. So we'll use our own answer. So first of all, we must find the number of moles of chlorine gas present in the sample, and then we will calculate the number of chlorine atoms in the sample of chlorine, diatomic chlorine gas. So in order to find the moles, we'll use the formula mass divided by molar mass. We got our mass from part 1, which is 0.232. We'll divide that by the molar mass of diatomic chlorine gas, which is 2 into 35.5, and our answer for moles is equal to 3.26 into 10 to the power negative 3 number of moles. Now this much number of moles we have in our sample of chlorine gas. Now we will convert this number of moles into number of chlorine atoms. But before we do that, we must consider 2 over here. This isn't just Cl atom being a gas. This chlorine gas combines 2 chlorine atoms. So this number of moles is for 1 chlorine atom. So we must multiply our answer with 2 to get for the diatomic chlorine gas. Now we must convert number of moles to number of atoms. You all must know that 1 mole is equals to 6.02 into 10 to the power 23 atoms. 1 mole has this much number of atoms. So 3.26 into 10 to the power negative 3 into 2 will be equal to, we will cross multiply this with this, and then we'll multiply this number of moles with this number of atoms to get the total number of atoms present in this number of moles of diatomic chlorine gas, and our answer is 3.93 into 10 to the power 21 atoms of diatomic chlorine gas. All right. Part 3. Chlorine gas does not behave as an ideal gas under these conditions. Explain why chlorine behaves even less ideally at very high pressures. So conditions for ideal gases are their volume is negligible as compared to the volume of the container they are being preserved in. They make inelastic collisions. The molecules do not experience any kind of attraction or repulsion. So at very high pressures, chlorine gas will definitely be of big sizes. So size of chlorine, so size of chlorine gas molecules become more significant at very high pressures. So we cannot ignore this fact, and we can't say that at very high pressures it still acts as an ideal gas. And the next is at very low temperatures. Now when we lower temperatures, things usually experience contraction, and so does chlorine gas. So we'll write intermolecular forces become more significant as contraction takes place, because then they experience high force of attraction. The molecules will experience high force of attraction. Now if you want to watch the rest of the video, you can visit our channel Exam Help Web.